vulcanization. Silicone molding technique came out after World War II. Very effective, great at being able to take and reproduce a part. A lot of people who did this work initially thought of themselves as artisans, didn't want to share any of the technology, and a lot of it's gone by the wayside. There are still a lot of people out there that can do some really good work with it, and it's a very effective tool for reproducing parts that are made off of additive manufacturing machines. Different types of casting could be gravity, pressure, vacuum cast molding, thin wall reaction injection molding, or even rotational molding for blow molded or roto molded parts. So these are different tools to help get you to a product that's going to give you more representation of what it is that you're looking to produce. Materials, again, polyurethanes, epoxies for higher performance, polyesters for cheap, wax if you want to go to investment casting, and silicones, as we were mentioning there. Some of the machines, these are some of the older machines, but still very prevalent. The 3D System stereolithography machine. Then you've got the FDM machine. It used to be their flagship, the Titan. It's still the same basis of everything they have for their equipment right now. The MC400 is the same as that one. And the Center Station from DTM, which is now owned by 3D Systems. These are just laser sintering options, fused deposition modeling. They're different processes. How many people are familiar with the ASTM F42 terminology? Okay. For those of you that aren't, ASTM F42 is a group that was started in January of 2009. They embarked on defining standards for additive manufacturing so that people would actually be able to buy product by calling out a specific ASTM spec like you would any test method, and the manufacturer then knows how to be able to produce the product. They've come up with, have come up with 7 different categories that all of these additive manufacturing systems fall into. And to briefly go over that, and this is a little digress, so I'll hit it quick. You've got vat polymerization, which is stereolithography and other similars. You've got extrusion, which is FDM, MakerBot, any of these little desktop printers, Cubify. You've got powder bed fusion, which is your direct metal systems that are powder bed, as well as selective laser sintering. And then you've got direct energy deposition, which is much like the Optimex system, where you're actually doing a powder feed to an area where you have a point of directed energy, and then using that to move your melt pool around. And then you've got, well, even this lamp process, which is one of the largest machines, unfortunately not in service right now. And then you've got material jetting and binder jetting, as well as sheet lamination. The sheet lamination, much like the LOM system, laminated object manufacturing. There's a Cura system out there that does paper. There is an MCore technology that uses paper and bonds the layers. There's also the Solidica system, or the ultrasonic consolidation system, which actually ultrasonically bonds layers of metal to prior layers of metal. Edison Molding Institute is doing a lot of development on this. They came out and spun off a company by the name of Fabrisonic, which actually manufactures a line of these ultrasonic consolidation systems. So that gives you a little bit of the overview on some of these. The one here is actually an RCAM system, which is an electron beam. It's a powder bed system. As opposed to using a laser, you're using an electron beam. Very strong power source. You can split it up, run 50 different points of energy deposition at the same time. The real difference with a lot of these is, what's the output? What do you get at the end of the day? When this build finishes and you've got a part coming off of it, what do you have? How can you put that into service? Or do you need to do secondary operations to make that thing function?